All right, we're gonna get started now, guys and girls. Thank you all for joining me again today. The what we're gonna work on today is inlays. Doing an inlay is an awesome way to enhance a project. Whether it's something as simple as maybe you're making a cutting board and you want to inlay a nice little decorative design into it, or the top of a jewelry box, or in your sign, whatever the case may be, just to give it a little extra pop, a little extra, um, wow to it. Inlays is a great way to do it. And so we're going to be working with two different types of inlays, and let's get into this. So this is going to be a single-sided project, of course, and I've got my project board up here set up for a 24-inch by 10-inch. And I've got it set for the actual board that is going to get carved on is 3/4 of an inch thick. Now, when you're inlaying, you're going to have two separate VCarve files. One is going to be for your sign or your design and everything, the pocket of the female, and then you're going to have another project that is cutting out the male part of the inlay, because normally you're cutting that out of either a thinner piece of material or a different piece of material of a contrasting wood or color, so that you can inlay it into this project. So you'll be creating two separate projects for that male cut, but everything you're going to see in here, you're going to see me creating them side by side and things. You'll just I'll keep reminding you guys of how we'll create that second project, and I'll show you how we can do that. So I'm going to be working off the top of the material and off the center. Let's go ahead and click OK and get into here. So there are two ways of creating inlays, and let's move over to the toolpath operations, because these are the toolpaths we're going to be working with. We have the inlay toolpath for your traditional style inlay, and this is called the auto inlay toolpath, and I'll explain to you why it's called the auto inlay toolpath. But we also have an option of doing what's called a VCarve inlay. A VCarve inlay gives us the opportunity to get really nice detail and really sharp points and everything on our design, and it uses a V-bit, unlike a traditional inlay that would use a straight bit. So let's take and pop back over here, and let's talk about why the auto inlay toolpath is the way to go when we're doing inlay. So I'm just going to create a letter here real quick, and we'll just do the letter H. Go to make it about 2 inches tall. Make that a little bit bigger so you guys can see what's going on here. Okay, so let's imagine, and I'm going to make a copy of this. I'm going to hold down while I'm in transform mode, I'm holding down the control key, and I'm going to come in here and just drag a copy off to the side. And so one of these, the one on the left, will represent our male part. The one on the right is going to represent our female part. And the one thing that I want to show you is, if we were to think of this, we're cutting a part out and we're cutting a pocket, right? We're cutting a profile cut and a pocket. The only problem is, if we just use the regular profile and pocket tool paths, we have issues because our router bits are round. So let me explain to you what I mean by that. We have these nice sharp corners here on this H, and if we were to carve this out on our inside corners here on the H, here, and here, we're going to have a radius. So if I were to create just a profile tool path on this, and let's cut all the way through my material, and let's use a 1/4 inch end mill is fine for this. Oh, hold on. The screen went black. Is it still we still grayed out? Screen is black. All right. Hold on a second. Stand by, guys. Let's see here. Load. Are we still gray? Other than the two little gray boxes that are... All right, still grayed out. Okay. So I'm just going to do a... We back? Are we back in business, everyone? Okay. Let me move a couple of things off my window here. All good. Okay, great. Thank you for letting me know that anything like that ever comes up, definitely jump up and tell me. All right. Stand by. Let me grab a couple of more things. Okay, so we are good to go. Everybody can see us now. What I was saying was, if we were to just simply use a regular profile toolpath and a regular pocket toolpath to try to create this inlay, we would have major issues. And what I mean by that is when we do a profile cut and we're cutting outside an object, if this was my male part here, well, I'm going to get sharp corners on the outside corners, but on these inside corners here, like I have 4 inside corners on this H on these 2 lower parts, they would be rounded. And let me demonstrate that. So if we go through my material, and I'm just going to use a 1/4 inch end mill outside of the cut, and I'm going to keep all the default parameters here and just calculate this. And let's go into straight on view. If I were to preview this cut, and zoom into it, we can see that on these inside corners here, they get rounded because of the radius of the router bit. And that would cause us problems with fitting in to our female. So let's create that female pocket just using the straight pocketing toolpath. And this one will go 0.2 deep. Always use the same bit that you cut your mill with. So I'll use a 1/4 inch end mill. And I'm going to just keep the default parameters here. And if we previewed this toolpath, we can see that, let it finish pocketing out to that depth. Should have done it in one pass. You typically want to do it in one pass so you don't have a step down. But now if we look here at the female pocket, we have these sharp corners. So as of now, we have a mismatch. And then on our outside corners, which are square here on the male, are rounded on the female. And so it's a mismatch. Well, we have the fortune of having what is called the auto inlay toolpath operation. That's this icon that's on the top row of your toolpath operations. And the auto inlay allows us to create our male and female part, and it takes an account and adjusts for the radius of the router bit. So if we go back and create our straight now using the inlay, and you have, notice I have 4 options here. For the male part, we have a straight and a stepped option. And for the female pocket, we have a pocket and a hole. Now I'm going to just talk to you about the straight and the pocket right now, and then we'll come back and talk to you about the step and the hole, because that actually is a whole nother neat little creative thing that you can do, and we'll do that one in just a minute. But let's start with just the regular straight inlay. And so we're going to click our male inlay pocket, and again we're going to cut through the material, and of course I've got this material set at 3/4 of an inch. I'm going to use the same 1/4 inch router bit, 1/4 inch end mill. Outside of the cut, I'm going to keep all the parameters the same, and we're going to calculate this. Set this preview. Now, if we were to preview this toolpath, we can see that once it cuts out, if I zoom in and move over, the router, the toolpath has accounted for that rounding of the corners instead of getting sharp corners. So now we have that radius all the way around, and this is best viewed if we look at it in our split screen view. So if I go into split screen here, and if we look at this toolpath in a solid state, bear with me a second, let's go back into preview there, you can see the toolpath and where it's nipping off this corner here and coming in. It's showing you the radius and everything. So it's accounting for that 1/4 inch or 1/8 inch radius on a 1/4 inch bit already. Now let's go ahead and go through and create our female, sorry, inlay. We're going to do a female pocket. And I said male pocket earlier, I meant male profile. Sorry about that. Again, we're going to go 0.2 deep using the same 1/4 inch end mill. I'm going to leave the default parameters the same here, and we're going to calculate that. And now if we look at the 2D view, you can see where this blue area, by the way, is a solid state. So if you have version 9, you have the ability to view, if you ever see those arrows and lines on your software that's showing you the toolpath, well, you can view, that's the wireframe mode. You can view solid mode too, to see that solid mode. But if we look in here now, we can see that rounding of the toolpath. So we're going to end up with that perfect fit. It automatically accounts for the male and female. It knows that we're trying to get this part into that part, and it accommodates it so we can have a perfect fit. Now if we preview the toolpath down below, and I'll maximize my 2D view again once it finishes cutting out that toolpath. Maximize this up. We can now see that on our outside and inside corners and everything, we have a perfect match. Now, when it comes to using the auto inlay toolpath, it's going to be a very tight fit depending on your machine. Now, you guys are all Digital Woodcarver customers, so other people, everything. Inlays, accuracy, and how tight the fit is, and all, it all depends on the accuracy of the CNC. We have on the Digital Woodcarver, you have a tolerance, which really doesn't mean much to you, but you have a tolerance of 3/10,000ths of an inch. You have an accuracy, if you were moving back and forth, where it lands in that same spot every time. You have a resolution of about 5/1000ths of an inch, but that 3/10,000ths of an inch, your tolerance is pretty tight. But tolerance doesn't mean anything. It's the word resolution. I'm sorry, 3/10,000ths of an inch resolution. That doesn't really accommodate anything. There's nothing we can equate that to in a project. Tolerance, when you, like if I were to set my XY0 and move the machine to one end of the table and come back, I'm gonna either, you have an XY resolution or tolerance of about 0.005 of an inch, 0.005, and which is, pretty tight. But some machines like the Carve or something like that, where the tolerance is not tight, they could get away without having to create an allowance. And what I mean by that is, if we look at this toolpath here, we have the option on either the male or the female creating an allowance. And typically, for the digital wood carver, I typically would either go with a 0.05 or a 0.01, I'm sorry, 0.005 or 0.01 tolerance, 0.010 of an inch or 0.005 of an inch. And that will just make my pocket just a little bit bigger so my male can fit in, and have that nice perfect fit. And if we were to close out of the 3D view and go into the 2D view, let me show you what I mean by that. So I'm going to give this pocket allowance a 0.010 of an inch, 0.010 of an inch. And if I calculate this now, and we look at this toolpath, oops, in its solid state, notice my lines, I've now expanded beyond that line 0.010 of an inch. I've made that pocket that much bigger. And you're either going to make your allowances on your female is going to be outward, and the allowances on your male are going to be inward. So it's one or the other. Typically, you do not put an allowance on both. I'm a big advocate of putting the allowance on the female and not the male, because rule of thumb, you always cut your male part first, so that while the female is cutting, you can come over to your table and do a test fit. If the test fit is too tight and you're having a problem with it, then you can come in and make that allowance, add that allowance and make that pocket just a little bit bigger and run that toolpath again until you get that perfect fit. And notice on the male here, we are actually making the part smaller with the allowance. It's actually cutting the part smaller when you add the allowance to it. So you can either add the allowance to the male or the female. I am a big advocate of using the allowance on the female part, because you cut your male first, bring it over to the table while you're cutting your female, and while that female, when it finishes cutting, do a test fit. If it's too tight, go in there and recalculate the toolpath, giving yourself a little bit of allowance. Run that toolpath again, and you don't have to run the whole toolpath. You can just run the last, profile pass just to widen it up a little bit. Test fit again until you get that perfect fit. Once you get that perfect fit, and let's say our allowance is 0.010 of an inch for the perfect fit, you can pretty much guarantee that that's going to be the allowance that you would use each and every time. And so the allowance will help just kind of widen things out, on that female, and which is visually shown here in this 2D view. Okay, now that being said, let's talk about real quick the step inlay. So let me turn these off. The step inlay is cool. I don't know if you guys and girls have ever seen a project. Basically what we would be doing, if you look here at the toolpath, if you can see this little icon, we'd be cutting a hole all the way through. That pocket would be cut all the way through our board, our material. And then the male is going to be cut to where it has a lip on the bottom side, and it would be stuck into our project from the back side of the board, and the lip would stop it, from protruding, from slipping all the way through, just like like one of those games, hole in a hole pegboards or whatever. But it stops it, and now it creates a project to where we can have a contrasting material kind of almost extruding up off of our board. So let's do that. Let's create a stepped inlay for the male side of this H, and my cut depth again is going to be 0.75, you know, cutting all the way through. Now we have, and let's choose the tool. I'll go ahead, I'm working with a 1/4 inch end mill here. And by the way, your radiuses and all that stuff, it is bit based. For your smaller projects and all, 1/8 inch end mill, you know, you'll typically be working with. And typically you're not cutting a male part out of a 3/4 inch board. It's usually a thinner, you know, piece of material, because you're only cutting the female pocket to about 0.2 or 1/4 inch, a little under 1/4 inch. But let's go with a 1/4 inch end mill. Now we have a new window here for this step. It's asking us what our step depth is going to be, and that's, it's probably hard to see in the window, but the little graphic here, the step depth is from the top of our board down, what that depth is. And one way that we can do that is we can use, I usually leave about you know, 0.2 of an inch or so of a lip. So I can use a shortcut, and I can say D, which is the depth of my project, and I can say times, oh wait, hold on, bear with me, there's an equation. Oh gosh, I'm trying to teach you guys and I don't even know the own equation. D for my depth minus 0.2 equals, oops, syntax error. Stand by, guys. Forget that. We'll just say, let's go point. I'll give you the equation here in a moment. I'm an idiot. All right, 0.625, and then my width, how wide it is, usually only about you know, 1/8 of an inch. I'm not going to do any allowance offset for this. I'm going to be on the outside of the cut, leave everything, the parameters the same, and I'm going to calculate this toolpath. While that is calculating, I'm an idiot. Everything can happen when you're live. I'm going to take a look at what that equation is. Gosh almighty. There is a, by the way, what's called, you have options for, where is it at? View, help. Right here, keyboard shortcuts, which is what I'm opening to look at. There's keyboard shortcuts. It's a list of you know, all of the keyboard shortcuts to show you what they are and everything. But anyway, let's preview this selected toolpath. I tried to be fancy and show you a neat little trick, and I didn't even know how to do it. Now notice what will happen. Watch here as it cuts this mel. It's going to be quite a few passes. I've got my bits set for an 1/8 inch pass at a time, my 1/4 inch bit. I'm not aggressive with my bits, so give it a second to calculate that. We're almost done. And all right. Now if I delete this and we take a look at this part, notice how it's created my inlay part, but it's left this lip. And the lip is so when it slides through the hole in the back of our, you know, our project art that we're cutting out the female part of this, it stops it. It's kind of like a stop. And you would typically, it's also room for glue. You'd put a bead of glue in there because you know, it'd be glued in from the back. And you typically have this mel a little bit thicker, like let's say if I was using a 1/2 inch board, then my mel would be cut out of about a 3/4 inch board. So that way when it sticks through the hole, it's protruding above my board about, you know, an 1/8 of an inch or a 1/4 of an inch. It's just kind of giving it that raised up of a contrast wood. So let's cut the female real quick. And with the female, it's a very simple hole. Again, we're gonna, you know, go all the way through my material. I'm gonna use my 1/4 inch end mill. And I'm gonna set this pass depth to a 1/4 of an inch, just to speed things up. We're going to be on the inside. No allowance right now, but again, if you need to make it a little bigger, put in that 5 thousandths or 10 thousandths allowance. And I'm going to leave all the defaults the same, and I'm going to calculate this. And let's reset our preview. And now we can preview our female getting cut out, and I can get rid of that waste. And again, if we preview our male, we can see our 2 parts, and our male will fit inside of the female all the way through it, again being stopped by that little lip on the back. And it's a really neat thing. Signs for kids' rooms and stuff, and all kinds of stuff. It's typically used with acrylics. Let's say that we were carving an aluminum or a wooden sign, and then we had some thick acrylic that we were going to backlight. We would cut the male parts out of that acrylic, and it would come in through the back, and then we would put LEDs and stuff and make a really just a very cool looking sign. But that is our traditional auto inlay toolpath, just an overview of them. They accommodate, or they account for the bit, so that because it knows we're trying to fit this part into this part, and it accommodates for the bit on both parts, so we get that perfect fit every time. Now, stand by and let me, because if you're asking me questions or anything right now, I do not have any of the windows open so I can view what I was trying to view. I cannot believe that I didn't know it. All right, while that's doing that, let's go back in here and delete these. And let's open up a project that I've created. Now, one of the things that you're going to get out of this class, you're going to get a file of vectors for every state in the United States. Every vector outline for all the states. I'm going to provide that file to you as a gift, as a thank you. And this is one of the signs that I really like to make. And it is, the state itself is inlaid. I use maple. The state itself is pocketed out, and then the male is cut out of walnut. And then my star would be another piece of maple. And then my home is walnut. So if we were to actually view what this looked like as an inlay project, it would look like this. And use your imagination. The brown is supposed to represent the walnut. But I'm going to show you how to make that. And get distracted here. Okay. Inlay, inlay, inlay. H. I'm doing a test. Oops, wrong one. Close. Inlay toolpath. T. minus 0.125. Oops, 125. There we go. It's the letter T for thickness. Duh. That was my idiotic thing. Okay. So T for thickness. So what you can do is, let's imagine that you want to leave yourself about 1/8 of an inch lip. For that step depth here, you can use the shortcut T, which is the thickness of your material, minus whatever the size the lip is, and then the equal sign, and it will tell, and then it will put in the depth of what that step depth is going to be. So T is the shortcut. All right. And yes, let's stop for a second and answer a question. So you will have the lip on the back of your board. Yes, John, this is typically kind of a sign that would hang up on the wall where the back would not be seen. So you would have that lip on the back of the board, and the part would be coming all the way through. And let's take a look at a couple of other questions. Would you normally still use tabs for any full cutouts? Now, when I do inlays, I do not use tabs because I don't want to risk sanding or deforming my inlay. I want that perfect fit, and I don't want to sand and screw it up. So when I'm cutting my male part out, I just watch it, and as it cuts out, if I have to kind of hold it down or something when it's doing that last little cut through, I do. But I normally do not do tabs when I'm cutting the male part out on an inlay, because I do not want to screw up my inlay by having to do sanding and removing that tab. But let's get into the sign, and let me show you how I made it, and some of the things that you want to look at to overcome when you're working with your text and stuff. So let's create a new layer, and I'm going to call this class sign. And we're going to turn that layer on, turn that one off, and get into full view so you can see what's going on. Let's come over here, and thank you very much. Still getting used to where 9 all the icons are located at. Okay, so one of the things, like I said, is you're going to be getting a file, and that file, let's see here, is under downloads, down to you, STU, right here, United States Master. This file is going to consist of interchangeable files and source files, original AI type files and everything. The interchangeable files are just like DXF and PDF and SVG, but you're going to get a file folder, this entire file folder with all the states. They're DXF files, SVGs, PDFs. You'll have 3 different file formats. And you're going to also, it'll come with the originals, which are just PDF and AI, like Adobe Illustrator files, and then source files, again, which are just all AI files. But for when you're bringing them into your program, you're going to use what's called the interchange files. And so if I come in here, for me, I like using DXF files. If I bring in my DXF of my state of Florida, and notice that it did not show up. That's because it came in under the layer state. So if I turn that on, there's the new one that I just brought. It's got an it automatically creates a layer called state. So this file here that's selected, oops, this file here that's selected, we're going to move it to the Sign class layer. Now notice I only grabbed the state. I didn't grab these little islands and everything because they're not going to be part of my inlay. So I'll just end up deleting those in a moment. But now we can turn that layer off and we're back in business. So again, let's get everything out of here. So these images that come in, they're going to look like this. I'm going to F9 to center on my project. You don't need the outside frame, of course, so just delete that off. And you'll have all the states and vectors and all. Now, if we take a close look at this, you wonder how in the world is it going to inlay, this little, island or tributary or peninsula, whatever you want to call it, this little thing sticking off the state. Well, if I come in here and I create the toolpath for it, and I'll just use a regular inlay toolpath, straight mill, again cutting through my material, 1/4 inch end mill, and calculate. Actually, that was idiotic of me. I'm going to stop that. Wrong bit. I would not ever use a 1/4 inch end mill for this. I would actually, for my state of Florida, I would use a 1/16 inch end mill, but an 1/8 inch end mill would do fine as well. So we will, and I'm going to do this in one pass. I would not, again, I'm just setting this as one pass for, to make things quicker for the demonstration, but I would not run my 1/16 end mill 3/4 of an inch deep in one pass. So I'm just going to calculate that, and this is just for one more time. Edit passes. 1. Set. Okay. Calculate. It'll take a second to calculate that. It always, for some reason, takes me longer to calculate when I'm running a class. I don't know why. But let's reset our preview. And now if we look here, and we can definitely see a better view of it in the 2D view. So let's actually go over to the 2D view. And if we look here, you can see where it's compensated for the radius of that bit. So it's cut that peninsula off. Okay. So we're just going to get that rounded profile and everything. So if we look at our 3D view, you can see what that, that peninsula is gone and everything. So it automatically kind of accounts for that. Just keep that in mind. Any little tributaries or whatever you want to call them, they're not going to get cut. They're not going to get cut unless you have a micro bit to fit in. So if I were to remove the waste material, this would be, let's get it into full view so you can all see it. This would be my, my mel inlay. And I still get good detail, on the state and everything. But those little twigs and all sticking off, it's not going to cut. So just keep that in mind. You're not going to get the 100% exact, on something that's so detailed as this, but you will. Now, and again, we're still using the traditional auto inlay toolpaths. We haven't even covered VCarve toolpaths, which is completely different. So these states, basically what I did from here is I created my toolpaths, and let's go into full view so you can see what's going on. I don't know why I keep clicking everything. Bear with me a second. Okay. What I'm trying to do is move this over to where it belongs. All right, now text. Inlaying your text. Let's go over and create some text. I'll just create the word home for this. My computer must be struggling for some memory now. Gotta run. Thanks. I'll watch. Thanks, Ronnie. Sorry. Am I running over? No, we still at 7:40. Home. And for this tool, I will use. What's a good one to use here? And again, just know that when you're creating your sign and everything, your sharp corners here, they're going to have those radius depending on the size of the bit. So if you want a very non-noticeable radius, use a smaller bit. Use your 1/8 inch bit and everything. If you use a 1/4 inch bit, then you're going to have a wider radius and all. But you do not have to go into this text. You do not have to go in and change all these corners or anything. That auto inlay toolpath will do it for you. So if I were to come over here and create my, I'll just do the pocket for this one. Come in here and create that pocket. 0 start depth, 0.2 cut depth. I'm going to use an 1/8 inch end mill. I could stick with the 16th, but I'm not going. That's too small of a bit for pocketing. I could use a 16th and an 1/8 inch or a 1/4 inch or something, a larger area clearance tool. If you have a big area to pocket out, definitely a time saver, but that does include an additional bit change. So if I calculate this, and if we were to preview it, reset our preview, and preview it, we can see here that on the outside corners, or outside and inside corners, it's accounted for the radius of that bit, and it's rounded those corners off, knowing that we're about to try to fit a male part into that. So by a show of hands, how many of you got that, and we can move on to VCarve inlaying? Do me a favor and just raise your hand so we can move on. All right. Todd or anybody, if anybody has any questions, Larry, Ken, we can always, if ever you want to ever try to do what am I trying to say, an inlay project, pick up the phone, give me a call. I have no problem walking any of you guys through your first inlay project, or multiple inlay projects. I have no problem being there for you to help you out. So let's clear that. All right, let's focus on VCarve inlaying for a minute. VCarve inlaying is very cool because now we are not limited. We don't have the radius anymore that we have to contend with. We can get very sharp corners. We can get very intricate in our detail and everything. Notice on this owl here, we have some very sharp points that we come to and everything, and we're going to be able to maintain that detail. Now what you see here is I've got my female pocket on the left this time, and I've got the male on the right, and notice that the male has this border around it. And what we're doing is, and again guys, you see I'm creating these male and females out of the same material board. We would not do that. You would actually create a whole nother project for your male, cutting it out of the proper size, thickness material, and the proper size. You don't want to cut it out of a big board. Cut it out of a board that, whatever size it is, that'll fit. For instance, on my owl here, if I was cutting this male out, if I look at the size of it, it's only 9 by 5, so a 10 by 6 board is what I would be having clamped on my table, cutting it out. And you would create that in a separate project. And you can copy your vectors from one to the other. So if I were to open a second instance, right-clicking on my little Vectric icon down below on my screen, and open a second entrance, a second VCarve program, I would come in let it pop up here. Oops. Let me close some of these windows, guys, because we're having some lag. Okay. I would come in here, create a new file. This file would be a... Oh, I am lagging, seriously. 10 by 6. And, you know, cutting it out of a, you know, my pocket is going to be 0.2, so I might be cutting this out of a 1/4 inch board, a 1/2 inch board. The thicker you go, the more you have to sand it flush. Or you have your CNC mill it down. I would cut this out of a 1/4 inch board, and I can come in, click OK on this, and I can paste. Oops. I had the wrong one copied. Let's go back over here real quick. If with that selected, I can copy it from here and paste it into here, center it onto my board, and this is what I would create, you know, cut my mill. I'd create my mill inlay toolpath and cut it out. Even for the VCarve as well, because we're going to actually use the VCarve. This is the VCarve tutorial here. But when it comes to traditional, this is what you would do. You create a whole separate project to cut it out. Now, if for my VCarve inlay, my project needs to be a little bit bigger. So I'm going to give myself a little bit of room, and I'm going to go 11 by 7. Because I want to create a boundary, and I'm just going to draw a rectangle around this, snapping from one corner of my board to the other, drawing that rectangle border. And I want to create a boundary around this because we're going to be carving, when a VCarve cut gets done, it leaves a mill behind. So let's see if I can give you an example. I don't have a visual. I do have a visual. What am I, an idiot? I created the toolpath. Let's go over here. Sorry. I don't know why I got flustered there for a second. VCarve. Bucket. Let's see here. This is my... No. Oh. Bear with me a second. All right. This isn't the owl, but don't get confused. Preview selected toolpath. When we have that boundary around our mill part, the back of the board is still going to be attached. All of our basically still be attached to the to that board. And when it VCarves, we would end up cutting, you know, of course we'd be carving this out of a smaller board, but we make sure that we have no lip around here. You take it to a table saw or a bandsaw, cut it out, because this whole backer and everything is going to flip and fit onto and snap into your female part. And if I can pop open a window real quick, let's see if I can do this. I'm sure many of you guys and girls might have seen what a VCarve inlay looks like, but let's see if I can get a picture of it. VCarve inlay. There is a PDF tutorial that this method of VCarve Inlay was created by a couple of guys called Paul Zank and Damien Durant. Named, not called, but Paul Zank and Damien Durant. And they actually have a full PDF, which is here, this VCarve Inlay project. that is printable. It's 15 pages that walks you through all the steps. The only thing is I think the PDF actually has a typo because of their cut depth and start depths, and I'll show you that just one second, but I want to show you should have had all these windows open and ready for you guys. And while that's loading, when cutting an inlay, would you adhere the veneer to a wasteboard or sandwich it between sacrificial? Debbie, if you're doing a veneer, if it's going to be that thin, but our inlay pocket and everything is almost 1/4 of an inch thick, 0.2. You can go 1/8 of an inch. You can go 1/16 of an inch. If you were going to do it with a veneer, then yes, you would sandwich it between 2 boards so it don't tear out. But the mill is going to be actually pretty thick, especially on a VCarve inlay. Even with the traditional inlay, I mean, our inlay depth, pocket depth was 0.2, almost 1/4 of an inch. And so it would be pretty thick. There would be no need for me to put it through or sandwich it between 2 boards to cut it out, if I was worried about tearing it up or tear out. It's not going to be that thin of an inlay. All right, how many of you can see this screen, this PDF screen? Yes. Okay. So when that mill gets cut out, it stays on the backer, and all the parts and everything get, remain intact. It doesn't cut all the way through like you would think, because when these 2 parts come together, the male and female are going to snap together like you'll hear a nice little satisfying click. They click together very nicely. And so when they're done, there's a space. If you can see on page 12 here, this page here, this kind of cutaway they did, there's a space between the male part and the female part to where you can run a handsaw or a bandsaw to separate them. When you separate them, then you would just go ahead and sand that flush in your female, leaving you with your inlay. But so that female back is that male backer, it's not going to get cut through like it would with a traditional inlay. You're not cutting the male all the way out. So if we come back over here with our owl, I want that border around, and I want to, one very crucial important step is I need to mirror the male, because think of 2 slices of bread coming together. If you can see my video still, 2 slices of bread coming together, those 2 parts coming together, we need a mirror copy of it. So I'm going to come in here, I'm going to just flip it and mirror it. You didn't see any real movement there, just a quick shift, but it is now a mirrored copy. And I can come over here, and for your male VCarve toolpath, your cut depth is going to be 0.1. Your flat depth is going to be 0.1. Don't ask me why it works, but it works, and that's what the settings are, and they will never change. For the male part, 0.1 start depth, 0.1 cut depth. I'm going to use a 60-degree V-bit for this. You don't have to use a flat area clearance tool to flatten all of this area out. The V-bit will do a good enough job for it, but makes it a little bit longer run, so I like to use a flat depth, and I can calculate this toolpath. And if we were to preview this, you can see that this would be my male part. Yeah, and yes, Ron, sorry, Ron was asking a question about, do you have to reverse the male image so that it'll fit in the female? Yes, you do. So this is my male part, and notice on the edge of my board I have this little lip. I would either take it and cut it off with a chop saw, miter saw, run it through a bandsaw, run it through my table saw. We just want to cut that lip away so that it's not there. And so this would be our male part. Now let's pop back over and create the female part. And this is my female part. My male, remember, has the boundary around it. So if I were to calculate VCarve Inlay, the female toolpath is going to have a start depth of 0 and a cut depth of 0.2. Basically, that 0.1 and 0.1 of the male, we are splitting this 0.2 depth in half. So our female goes to a depth of 0.2. Our male it starts at 0.1 and goes to 0.1. And that's because the VCarve, again, I'm using a 60-degree V-bit. I do not need a flat area clearance tool on this. And if I calculate this, we'll see reset our preview and take a look at that. We've got our female here. The reason why I don't need a flat area clearance tool is because the V-bit will flatten that area out, as well as it needs to be flattened out. But that room down below is, my glue and everything. It's going to be glue. It's going to be hidden. It's going to be seen. So I don't need to waste time changing a bit for that. So my female cut, and just for kicks and giggles, this has already been mirrored and everything with the boundary around it. Let me just quickly create the male here so you can see them side by side. VCarve toolpath, 0.1 start depth, 0.1 cut depth, 60-degree V-bit. I will use a flat area clearance tool on this. And calculate. If we preview the visible toolpath, you'll see the male. And so what the VCarve method does, and see this angle, if you, by the way, 60-degree V-bit, 90-degree V-bit, 180, doesn't matter what angle bit that you use the same bit for both the male and female. I really like and prefer using the 60-degree V-bit, but in that PDF, and I'll provide a PDF in the project files too, that PDF, they use a 90-degree V-bit, but it doesn't matter what angle. You just use the same bit for both the male and female. And so what happens is why the VCarve Inlay is such a great method is because, one, we get these nice sharp detail corners. We don't lose or sacrifice any detail by the radius of the bit. And what happens is that angle of that cut, when those V walls fit together, it will push down and kind of, like I said, give it a nice little satisfying snap together until those walls meet, and it will stop. And that's it. And it gives you a nice, clean, VCarve inlay. And you're really not limited on the type of projects that you would inlay with a VCarve toolpath. With traditional inlay, we have to worry about, we can't have a project that's too detailed. So for instance, if I were to turn off the owl here and show you our hummingbird, notice on this hummingbird, I mean, we have some very small lines. First of all, it's very thin, very small to begin with. So we're going to get some very thin detail and stuff in here. And if I was doing a traditional inlay, I wouldn't be able to do it with this, because I would have to have a very small bit, or else it's going to, cut this project back to where that bit can fit. Well, with a VCarve inlay, I have the ability to create this detailed project. So again, female pocket, the male is mirrored with a boundary around it. The boundary doesn't have to be a rectangle. You can just draw a line, you're just outlining it. Just give yourself enough room so the bit can get in between the design and the that outline, to flatten it out, but to minimize your waste and stuff. But if we were to look at this hummingbird project, which if I'm not mistaken is, that's my owl. That's my Florida State. There's the hummingbird. Hummingbird. There's our female pocket and our male. You know, so we can get really nice sharp detail, you know, on these leaves and stems and everything. All right. So, any questions? This will be best going into Q&A right now, because I can demonstrate better if there's any questions or any type of, you know, project. But as far as just so you know, as far as your vectors and everything, just like you would, you can get vectors from anywhere. Just, you know, like your images, and you know, when you trace bitmap to VCarve, if you're VCarving this, it pretty much could be inlaid. You know, you just want to, you can't get too detailed, but you know what I mean. So let's see what we have for some questions. When you snap it together, I'm guessing the glue, you glue the female part first. After it sets up, could you run it through a planer and remove the excess? Well, you could, absolutely, for sure. I typically, if we look at our 3D view here, I typically put the glue on the male, you know. And I'm not worried about the glue getting onto the background here. I'm worried about glue getting around my background here, because this is my project board. But, and again, this would be two separate boards, by the way. But I'm not worried about wood getting here, because all this backer board of the male is getting cut away. So I typically put glue around my male, and I typically just do one side. There's no need to fill glue on both sides. It's way excess glue. You don't need that much. And that difference that, you know, that we created, that reason why we started the male at 0.1 and then went to 0.1 is because we need a little bit of space in here, in the bottom end here, for glue to go to, you know, kind of squeeze to, so it squeezes down into the inlay rather than out of it. And the what am I trying to say? What was the last part of that question? Running it through a planer. Yes, you could. But if you notice, if we look back at this picture here, when those two parts, and let's see if there's a better picture right here. When that male and female to go together, you have this wide gap in between them. And that gap is big enough for you to run a handsaw, a bandsaw, you know, or something between. You can put this project right on your CNC table and just do a face planing, you know, and just mill it, you know, run that CNC back and forth, do a pocket cut where you're running back and forth, where it mills it down to your top surface. I usually don't go all the way to the top surface. I leave about 10/1000ths of an inch exposed, and then I do the final flushing up with a sander, random orbit sander or hand sanding. But you've got this gap in between the two. So running it through a planer, yes, you could. But easier methods would be a handsaw or a bandsaw, or letting your CNC just mill it off. Well, your planer too. So yes. Let's see here. So would you use the VCarve Inlay for every project, or are some projects that work better with traditional inlays? I would not use the VCarve Inlay with every project. Let's go back to our VCarve here for a second. This project here, let me get rid of these little vectors right there. This project here, you could VCarve it, but I'm going to be cutting it out, you know, kind of big, because I'm also I'm inlaying walnut, and then I'm also inlaying another vector here, a star. And now if I did the traditional inlay on the star, my points would not be pointed. They would be rounded based on the radius of my bit. But I could do a VCarve inlay on this star and get these nice sharp corners. So I could actually do a traditional inlay and a VCarve inlay. And some people prefer to just do the VCarve inlay for every project they do. I mix it up. It's just kind of a case-by-case basis. Thank you, Jer. I hope the class uploads come soon. There's 3 class uploads, Jerry, on the website right now. The quarterboard class, texturing class, and the combining vectors class. Those are on the website, digitalwoodcarver.com, and click on the training page there at the bottom. All right, have a great day, and the other classes are coming up today and tomorrow. Thank you, Jer. Let's see here. How would you set a roundover on an edge? Good question. This, by the way, guys, and Larry, correct me if I'm wrong, we're not talking about inlay because you wouldn't do a roundover, but on the edge of your board, if you wanted to just do a roundover on the edge of your project board. So what you would do is, let's go and zoom out so we can see what's going on. We're going to create a boundary for our project board. I just drew a rectangle. Using the rectangle tool, I snapped to this corner, held down my mouse, pulled it over, snapped to this corner to create that boundary. And now you have to, the key thing is you have to add a roundover bit to your tool database. Thank you, Andy. I appreciate it if you're still with me. And now the Vectric tool database does have a roundover kind of defaulted in there, a 3/8 inch roundover, but you might not have a 3/8 inch roundover in your tool, right? So we're got to create that roundover. Let me delete this. So what we're going to do is let's say I have a 1/2 inch or an 1/8 inch roundover or what have you. I'm going to draw that radius. So if I have a 1/2 inch roundover, typically when you say 1/2 inch roundover, it's referring to the radius. So I want to make sure that my radius is radius is 0.25. There we go. And I'm going to go into node editing mode. And we need this top right corner of this circle. So I'm going to cut the vector here and here. And I'm going to delete the rest of that circle. And this is going to represent my roundover. Now my roundover bit would typically have a little bit of a flat area like where a bearing would be or something, or a cutter. So we need to know how measure your bit and find out how wide that bit is, where it goes from one side to the other. You need to know what that is. And we'll just create, oops. All right, once I have the profile of my roundover drawn, I need to join those 3 lines together to make it, I have 3 open vectors, I need to join it as one. And with that selected, I will now open my tool database. Over here, it looks like 3 router bits in the tool operations side. I will come down to New and click on Form Tool. And when I do, it will draw the bit out. And now it's going to put in the diameter of the bit The diameter is not our radius, by the way. That is just, the width of that router bit. Putting it in there. It's going to fill in a pass depth and a recommended pass depth and a step over. And then we're going to come in here and put in our speeds and feeds. So 50 and 20. Click apply. I could actually run up to about 75 on this because I'm just doing a roundover. But now we have that tool in our tool database. You have to add those form tools, those specialty form tools, your OG bits, your roundovers. You got to draw those profiles. And sometimes you can find vectors of those profiles, in different places and everything. But you got to draw out that profile to add it to your tool database. Now, if I come over here and let's go back to our project, grab that vector and I'm going to do a profile toolpath. I want to cut, only 1/4 of an inch deep. I'm going to choose my roundover tool. And I want to be on the outside of the cut, but I will be setting an allowance. So right now, if I did it on the outside of the cut without an allowance, if I calculate this toolpath, oops, let's select our vector. If I calculate this toolpath and reset my board to a blank board, if we preview that selected toolpath, you're not going to see anything happen, right? Nothing's going to happen because it's got the bit on the far outside. So I need to create an allowance, an offset allowance. And that allowance is going to be a negative. I want to go in. And I want to go in probably, I don't want to go in half my bit. I'm going to go in 1/4 of an inch. Calculate. And if we preview that selected toolpath, you can see that nice roundover. So let's look in the 2D view what our, if we look at our toolpath here, we have to offset that bit. Otherwise it's going to bring, the whole bit, is going to be on the outside here. If we don't offset it, we're going to get any cut. So by then, that negative 1/4 of an inch, it gives us that nice roundover. And again, if I reset my preview and preview that cut, you can see that nice roundover that we're getting. Okay, that's how you would calculate and create a toolpath. Who else lost audio? Anybody else lose audio besides Leonard? Leonard, is your audio back? Okay. We'll wait for see if Leonard's still with me. Okay, great. So you guys lost audio for a second. Is there anything I need to re-explain on putting in a roundover bit in your tool database to create a roundover toolpath? The roundover toolpath, by the way, is just a profile cut toolpath. Just the profile toolpath. And again, you're going to choose your roundover bit. You're going to choose your cut depth. And you're going to choose your step over, your offset. And when I say step over, your offset allowance. Okay. How do you set the Z for the roundover? You touch off your bit just like you do any other bit. You touch it off on the bottom of the bit, the very tip of it, the very tip. Okay, so no. You do not want to use a roundover bit that has a bearing. You want a plungeable roundover bit. And if you're like, oh, I don't want to have to go buy a roundover, but all Lowe's and Home Depot sells are the ones with the bearing, take the bearing off. Take the bearing off. And that little stub that the bearing slides on, grind it flat, nice and flat. You don't want to use one with a bearing on it. Okay, so Larry, let's talk about offsets, or allowance offset. If we look at this profile toolpath, let me cancel this. Let me turn the offset off. All right, my vector line, it's hard to see that pink line and everything there. Let me turn this off, uncheck it for a minute. My vector line here is the edge of my board, you know, that I'm rounding over. And when I create the toolpath, I've got the toolpath set for outside of the cut, okay? Well, if we look at our bit, it's not going to be in here. It's going to be in the outside of the bit on the one extreme or the other, left or right, depending on which side you're on. So it's going to have the outside of the bit cutting around that line, so it's not going to be cutting anything, right? So we have to bring that bit in so that we're getting that cutting area, you know, that roundover cutting area and everything here. So we have to bring that bit in towards the wood more so we can get that roundover cut. So if I were to, again, looking at this toolpath in a solid state, that blue line, that's our tool, by the way. It's cutting on the outside. Well, I have to bring it in. So the allowance offset, I want to bring it inward. So it's a negative. I'm bringing it in a quarter of an inch, which is about the size of my radius. If I calculate that, and we look at our 2D view, it now brings that tool in that quarter of an inch. So now we're actually cutting some wood. Did that clear up the confusion a bit, Larry? Or still got question on it? All right, Larry's okay. Yep, you got it. Okay. And it's the same thing when we were doing the inlays, guys. If we were creating that inlay pocket, if I just create that inlay pocket, you know, with no offset allowance, then my router bit, if we come in here and look, it's going to be cutting up to my line, you know. And then when I cut my mail, it's going to be a very tight fit. Very, very, very tight fit. You'd have to beat it in. We don't want to beat it in. We want a nice, perfect fit. So we will offset, give it an allowance. Basically, we're allowing it, giving it an allowance of, you know, 0.010 of an inch, 0.005. And now, if we look at that, now it's gone beyond our line, expanding this pocket by that much so that our mail can fit in much easier. We don't want it to be sloppy loose, so you don't want to use a big offset, you know, when you're doing inlays. But you want, you know, just enough so you're not having to beat or force these things together. You know, you want a nice fit. You want room for glue and all that stuff. You don't want a dry joint. All right, so after cutting the roundover, you would run a separate profile cut to cut it out, separate from tonight's presentation. Is there enough difference to merit purchasing version? Okay, two separate questions there, Debbie. So let's talk about that. So let's say that let's draw a rectangle here. Let's do the angle here. And I'm going to create a profile cut to do a roundover on it. And imagine this is just my board. I'm just working inside my work area because it's all I got to work with right now. But let's go, and we want to offset inward 0.25. Negative, going in. Calculate that. Reset my preview. All right, if I were to run that toolpath, course, you would see the roundover is cutting both roundovers because it's on both sides. You would then, now just like you were asking, Debbie, you would then create your profile toolpath to cut the project out. So if I profile toolpath, this time now I'm cutting all the way through my material, and I'm going to use a 1/4 inch end mill. And I'm going to be on the outside of the cut, and I'm going to calculate this. If we preview that selected cut, it will then, cut that piece out. So you will create your profile cut for your roundover, and then a profile cut for your profile cut, your cut through. Okay. All right. So, is the offset half the measurement of the bottom of the roundover bit? No, your offset, Larry, would not be half of the bit, because normally that bit has a flat bottom. If we take an actual look at that bit, if we take a look at that bit here, we have a roundover, and then many times the bit has a flat bottom on there. If I were to step over half the diameter of the bit, then now my bit bottom here is cutting in, and I'll get a lip. So as an example, if I took and did half of that bit, which is 0.375, and I calculate that toolpath, if I reset my preview and preview the selected toolpath, ignore this, I would be getting this roundover plus my cut. So we don't want to step over half the diameter of the bit. Okay. You want just a 1/4 inch, which is basically the radius from the edge, 1/4 inch over, because it's a 1/4 inch radius bit. If it was a 1/2 inch radius bit, your step over would be 1/2 inch. If it was 3/8, then your step over is 3/8. Because if I let me do the final profile cut on this this board, so you can see what I was referring to. Profile. End mill, cutting all the way through. Preview this like that. All right, so on my form bit, when I calculated, I went positive and not negative. You can tell that immediately. Negative. See what happened when I went positive? It went out further. Calculate that in, and let's preview that. Okay. This is what would happen if I went half the diameter of the bit. I'd end up with that flat bottom, instead of a nice roundover on the edge. Okay. And let's get that into full on view. So that would be a no. I would be mad. I'd be mad at myself. Be like, oh man. Our upcut, downcut, and by the way, Debbie, I haven't forgotten about the 9 and 8.5. Give me a second, I'll answer that question. Are upcut, downcut spiral and mortison bits the same as end mill, or can they be used as end mills? Okay, so an end mill is a router bit. A CNC bit is a router bit. It just depends on who you're talking to and what they call it. It's a router bit all day long. You either have ball nose end mills, VCarve end mills, straight end mills, upcut, downcut, or spiral cut end mills. An end mill is the same name as a router bit, or a CNC router bit is the same thing as an end mill or a router bit, if that makes any kind of sense whatsoever. So when you hear me referring to the term end mill, that's your router bit. So when you hear upcut, downcut, these are typically our flat bottom bits that are, like this picture here, there's typically flat. Upcut pulls the chips up when it's cutting. Downcut pushes them down. And then your compression has a combination of both. I'm going to be doing a video, an actual video of these 4 types of bit cutting. Your straight bit, which where the flutes go straight down. Normally it's a 2 flute straight bit. You have a downcut spiral. You have an upcut spiral. And a compression cut spiral. These 4 bits do different things, and they react differently in wood, especially when cutting plywood. So I'll be making a short little video demonstrating the cut quality of each one. Typically in your hardwoods, you're going to use an upcut end mill. Your plywoods, if you're pocketing out a cut in plywood, you're going to use a downcut spiral. If you're cutting through plywood and both sides of that plywood need to be clean and pristine, then you're going to use a compression bit, compression end mill. But even with hardwoods, you can use downcut spirals as well. And even plywood, you can use upcut spirals, but you're going to get a lot of splintering. I never use an upcut spiral bit with plywood. Lionel. Let me know if that explained it. But the word end mill is just referring to a router bit. So, yeah, and upcut, downcut, and compression cut, they're different types of bit, just the flute direction. Whether it's pulling the chips up or pushing them down or a combination of both. Those are 3 different types of bits, but all 3 of them are end mills. Okay, any other questions? Any questions on VCarve inlaying? And let's last one quick thing. Again, when you're VCarve inlaying, for the female, 0 start depth with a flat depth of 0.2. Always. Okay? 60 degree, 90 degree, 45 degree V-bit. Doesn't matter what V-bit you use. Just use the same V-bit for both. But these are your settings. 0 start depth and 0.2 flat depth for your female pocket on a VCarve inlay. For the male, 0.1 start depth and 0.1 cut depth. We basically took that flat depth of 0.2 that our female was cut to and we split it in half. 0.1 plus 0.1 equals 0.2. And again, 60 degree V-bit. So those are the 2 settings, and they don't ever change, for your VCarve inlays. The only thing that changes is your design. Pretty much, it's just every type of bit has a different look, and I have all of them. So your ball nose end mills will have a rounded tip. A straight ball nose end mill will have a straight shaft with a rounded tip. That's your ball nose. A tapered ball nose end mill comes to a point. It tapers down to a point, a conical shape, and then it has a ball at the end. Your end mill, which it refers to in the Vectric, your end mill is flat. Your straight, your spiral end mills or straight end mills. And then your form tools have some type of shape to them. Your cove bits, roundovers, OG bits, so on and so forth. Let's see here. And of course, your V bits have a V shape to them. And that's going to be your most common ones. Engraving bits, let me just say that your engraving bit has a V shape, but it has a flat tip at the bottom. And then you've got diamond bits, you know, diamond drag bits that have a diamond shaped tip on them. Okay, Michael Rose, any types of painting, multicolor inlays. The details must be to a bear to paint, merely mask or do something else in addition to. Oh no, on your inlays, your inlays you would typically use a contrasting wood. So my project board would be maple. My inlay, if I'm doing multicolor inlay, it would be I'm doing a combination of cherry and walnut and babinga, whatever, you know, if I'm wanting some different types of colors and designs. But if you're wanting to paint your inlays, maybe you're cutting all the parts out of pine and you want all those parts to be different colors, then you would not do the VCarve inlay method with that, because all those parts are, the top surface of those are all connected together. So, so yes, these are, yeah, the male parts are cut out of different boards, different, you know, on a different project board and everything. That's what I said. It's probably confusing because you saw the male and female being cut out of both, you know, this project board here. But you would set up two separate projects. You would have your project board where your female would be getting cut out of, and then out of a completely separate board and a completely separate file, you'd create a whole new project. You will be creating your male toolpaths, because you're cutting them out of completely separate boards, and those boards are typically contrasting in colors. And the let's see if this will load up. Come on, Google. We're almost done, guys. All right, let's look at some images here. And man, you can get super duper creative with inlays. I mean, all of these inlays. Anything that you see right now, you can do on your CNC machine. Every single one of them. But your inlays are typically done out of contrast, and man, you can really enhance and do some beautiful projects. One of the projects that I do is a cutting board, inlaid cutting boards. And if you guys ever want to see some really cool creative cutting board inlays on YouTube, MTM Wood, Mike Tango Mike, MTM Wood. That man makes some beautiful inlay cutting boards. But take a look at these as examples. You know, a cutting board with a state in the middle of it. You know, a nice decorative Japanese design and things. Now notice these inlays are running straight through the board. They're actually gluing up different contrasting woods. But then the band work and everything is all cut on the CNC and everything. MTM, yep, MTM, Michael, MTM Wood. That man he uses Vectric, he uses his CNC. He makes some beautiful, beautiful cutting boards. Oh my goodness. Awesome stuff. And let's see if, I don't even know if my, stand by one second. But get creative. I mean, anything you see here, none of this is out of your reach. You can absolutely do it. You know, whether it's something intricate, like I love this with the Marlon Brando. You know, where the his face and everything is the contrasting color and all. Very cool stuff. All can be done on the CNC. All right, so let's see here. Thanks for the class, Lionel. You're welcome, Lionel. He's one amazing Russian dude. Yeah, Michael, he is. I don't know if he's German, Russian, or what, but he is phenomenal. I love his videos. And everything. What I'm trying to do is I'm trying to go into my project album to see if I can show you one of my inlay cutting boards. And of course, like an idiot, I'm right back. Sorry, am I sharing this screen and recording the screen and all these screens and everything? Let me stop this. Stop. Oh, come on, Laney. You know how to operate a computer. But so inlays, that compass that you might have saw in the wood inlays and everything, the compass that we made in the quarterboard class, the vectors from that compass can be an inlay. You can use your models in your software. And by the way, let's get back to the software instead of looking at pictures. I'll show you pictures later. I was going to try to show you my cutting. Look at this. Let's say I want to do a Celtic inlay or something. I can go right over to my clip art, and of course I have you've got different type of clip art files. Let me get into them. You have different types of 2D vectors for basic inlay type stuff. But if I come down here to weaves, and let's say that I grab this weave right here, it's a 3D model, right? Well, come into the modeling tab, this little icon right here, create a vector boundary around the selected components. Click on that. It draws the boundary around. Now I can delete the model, and there's my inlay vector. I can do an inlay on that, and I have an inlay of that, and it does very well. It's beautiful. Looks great in a project. I can also VCarve this now. I don't have to inlay it. I can use this as a VCarve vector, and I just obtained it from tracing one of the models that came in the software. So think about that. There's a lot of little tips and tricks and stuff like that that you can do. All right, George, have a great one. Yes, MTM does do end-grain cutting boards, and his inlays are also end-grain. So he actually makes up an end-grain blank for the mels to be cut out of. What's the place to get vector images? Google, Ken. Google is the best place to get vector images. When you're doing a Google search, whatever it is that you're searching for, let's say we're searching for a rose. Type in the word vector after the word rose and hit enter. What this will do, of all the millions of files and pictures that it could show you of a rose, it's going to bring all of the highest quality images up front for us to view. So any of these, let's see if we can get it to show images. All of these now are vectors. These are, and they're going to come in as JPEGs or PNGs, bitmaps, GIFs, or TIFFs. They might not be a DXF or something like that, but these are high-res photos. You can bring them in to your software and do a trace and obtain your vectors that way. For instance, the mountain range that I used in the class, the second class, I got that off of Google. And once I traced it, I converted it into a DXF by being here. Like, say for instance, that let's say I just traced this, okay? I have this, I come over to File, Export as a DXF, and save it as a DXF file to my computer that I can bring it into other projects in the future, and then I don't have to retrace that image, you know, that I originally, you know, started with. Make sense? Let me know if that made sense to you, Ken. All right. Okay. Version 8.5 and version 9. If you have to purchase it, are all the upgrades? Yeah, when you go from version 9, yeah, you have a year of upgrades. 9, 9.08, which we're at now. We've already had an upgrade from 9 to 9.08. That's free. Any of those upgrades you get, there's 2 upgrades per year, and you get those. For 1 year. Did you ask, Debbie, let me look back up and see if you asked if upgrades were worth it. Let me see here. Is there enough difference? And that's what you were saying. Is there enough difference when purchasing? Yes, Debbie, if you're still with me, yes, it is. There's a lot of differences. One of the major key differences, and let's go back over to the drawing side here, is when you're in modeling mode and working with 3D models, the new mirror mode feature that we were working with in the modeling class, this allows you to create multiple things. You can mirror left to right, right to left, up or down. And what I mean by that is let me grab a model. Let's go into decorative. Pull this model in here. All right, so if I move my model to this upper left quadrant here, and I come into my modeling tab, I can now turn on mirror mode, and I can go from left to right. Now you won't see anything in the 2D view, but when we look in the 3D view, we've created this mirror copy, and what it does, it automatically blends that together. Now maybe I'm topping, so I have to move my top touching, so I have to move my model back a little bit. And, now let's say that I want to mirror top and bottom, on mirror mode, top to bottom. And let's bring this into where it blends together. So if I go into my, let's split screen so you actually see this. If I bring this model down, I can start to blend or mold those parts together till I can, and I have 400 in VCarve Pro. I have 475 models that I could blend and mesh and mix and mirror to create some beautiful ornate things for like mantles, headboards, the front of dressers, all that stuff. And so this little feature is totally awesome. When it comes to drawing, let's get out of this and this. Your new snapping features. Being able to snap to other geometry. For instance, let's say that I have, this circle here, and now I want to draw something down here in the bottom. Well, if I turn on my geometry snapping, and I have, smart snapping as well, I can come over and wake up this vector. And let me turn my smart snapping on. Let's close this tool, by the way. Oops. I can now wake up this geometry. That's what the shape I'm drawing. And wherever I touch off on this, now I can get lines, and I can say, okay, now I want to draw my line, straight in this area. Now maybe I want to come over to the center of the circle. There, I don't know if you can see it, a blue line just popped up in those two nodes on my circle up there. So that's my center point. And now I can come up here, that blue line showing me where the top of my circle is there. Come over here, and now, on the edge of my circle, I can now come, and you'll see that line draw there. And so we have these new snapping features where I can snap to anything, any type of vector geometry to help me draw, to tangents and stuff. So those new features are awesome. The new tools in the no, there's no new tools. Where's it at? Where's the new tools? There's new tools somewhere. Aspire got new tools. Sorry, Aspire got some new tools. Aspire got the new revolving tool for spindle type work, and making plate platters. A new modeling tool that's out there now. But the Vector Validator tool that's new here in Pro and Desktop and Aspire is awesome. If we have a project where our vectors are all screwed up, let's say that they're overlapping, we can come in and do a vector validation on this, and it will tell us that we have, if you look over to the right, one intersection, letting me know that I have an intersection right here, and that intersection is going to cause me problems with my toolpath. So it makes finding problems in complicated projects much easier. So now I know that I need to come over here and fix my intersection to eliminate that, or what have you. So there's tools. Yes, it's worth it. Now, you have Aspire, Debbie, so it's $400. Aspire there's a lot more options that became available in Aspire, so you can look at what's new on the Vectric website to show you everything that's new, and believe you me, it's worth it. But I'm not saying go spend money. You don't have to. Look at the tools, see if it's worth it to you. It's worth it to me, but my machine makes money, so my machine pays for itself. None that $400 is not coming out of my pocket. The money that I make from my sales pays for any upgrades, pays for my router bits, it pays for my wood, it pays for everything, and I don't have any out-of-pocket expense. If I'm having to just fork out $400, is it worth it? It depends on what I want to do. Do I want these tools to help me improve my design making and my project making, so I can, make more, make projects quicker and easier, so I can get out and carve and sell them? Yeah, it's going to pay for itself, definitely. But if you're doing this as a hobby, or if you're just something you're making Christmas gifts and stuff, it might not be worth that $400. So I'm not saying go out and spend money. And by the way, the $400, guys, is the price, the upgrade price for the Aspire to go from 8.5 to 9. It's not the price for VCarve Pro. VCarve Pro is $175, and Desktop is $75. And that's if you don't qualify for the free version of 9. Okay, so Debbie, for me and my needs and everything, it's absolutely worth it. Everybody's going to have to kind of evaluate it for themselves to see if it's worth it to them, because I do not like telling people to go out and spend money. But for me, it's a business investment, because it's going to pay for itself. It's part of my inventory, and that's what my profits go to, buying my upgrades and things. All right. Any other questions, guys and gals? Ask now or forever hold your peace, because I will be ending this class. It's already 8:50. If there are no more questions, if you wait for the next version, then does the price go up from the version 9? Yeah, it could cost you. I don't know what that fee or that fine, not fine, but what that extra charge would be. But no, it shouldn't. I think upgrade from one version to, like, if we were going from 8 to 10, it's still going to be $400 if I'm not mistaken. Debbie. Let's see here. Yeah, there's not going to be an extra fee. Sorry, I misunderstood the question. No, it should still be just the $400. Let's see here. All right, I do not see that I missed any questions, guys and girls. And while you're all here, before you start fading out on me, I know people have started leaving already. Next week's class, if you have not seen it, here's making a clock. Now this clock is going to have it's we call it American Fire clock, but the making the face and the numbers and everything can be universal for many types. The centerpiece here is, of course, the American Eagle and flag and all, but we can put all kinds of different designs and everything in, for all kinds of creative stuff. And this is the wall hanging clock. Oops. This is a wall hanging clock, and it's it's a two-sided project. There's a pocket on the back where the little clock gear mechanism and stuff goes. And then, of course, the handle goes through the hole. Making. Next week's class is a paid course, and there is a fee of $10. If you are interested in registering and participating in that class, this project class, you will be calling me, and I will put my phone number in the chat section if you guys have never called me before, which I think many of you have. My phone number's in the chat there, but you will call me to register because it is a paid course, and you can pay with debit card or credit card, or I can send you a PayPal invoice and you can pay with PayPal, all that stuff. But you do have to call for this class, for Thursday's class, if you want to register, and it doesn't matter what time of day or night you call me, just pick up the phone and call me. And I hope to see you guys Thursday. All right. Well, I really appreciated it. Hopefully I did not miss any of your questions. If I did, in the project files, all pertinent questions will be posted in those project files in the videos. Now, if you download a project file video and there is no Q&A in there, that's because all of the questions were answered in the previous project file. You can get the Q&A from that, and they were just a repeat of those questions. That's it. That would be the only reason there wouldn't be a project file in there, or a Q&A file. All right. Thanks, guys. Hopefully we didn't get too far off track, and you learned something about give the VCarve Inlay a try. Give the straight traditional inlay a try. Give inlay a try, period. I think you will really, really like it. Your first one, get it under your belt. Get that first VCarve Inlay at least under your belt, and every one of them after that's the same. Same thing with your traditional inlays too. The only thing that changes is your design. All right, folks. Have a great day, and I'm going to end here. Good night. Thank you, everyone. Thank you, everyone, for all the compliments. Thank you. Thank you. Wait, another question pop up? another question pop up. Oh, thank you guys. Okay.